Hi, in this video we are going to talk about HashSet in Java. HashSet is used to store a set of keys and it uses hashing to store these keys, hash tables to store these keys, and hash functions to convert these keys into indexes in the hash table. So it uses all the concepts of hashing. That is how it allows operations like add, remove, and contains. So these are three main operations on HashSet: add operation to add an item, remove operation to remove an item, contains operation to check if the hash set contains a given item. All these three operations are big O of 1 on average in a hash set. Let's take a look at the syntax. We create a hash set this way. This data type should be a non-primitive one. It should not be int, char, something like primitive, anything other primitive. It should be only non-primitive type like capital integer, string, or character. All these non-primitives are allowed. Even user-defined things are allowed. Your user-defined function, a class should have a function for hash code. We have added these three keys to this hash table. Once we created the hash table or hash set, now we add these three keys, GFG, courses, and IDE. Now we print the hash. So there's a toString function that prints the content of this hash set. So the output of this part is going to be GFG, courses, and then IDE. After that, we have called contains function. So contains function returns true if the given key is present in the hash table, otherwise it returns false. So IDE is present in the hash table, so the output is going to be true. So the contain function that we've called, add function we've called here at these places. Now we iterate through the hash table. So we create an instance of h.iterator, right? So h.iterator returns an iterator to the hash set. It implements the iterator interface. Now we call the standard function to get the items one by one, right? We call the next function to print the items one by one. This next function prints the next item until there are items. So has next ensures that there are items, and then we call the next function. So what is the output of this part? So we are printing all the items, so we'll get GFG, courses, and IDE. So we talked about these functions of HashSet: add, contains, and iterator. Few more things about add function before we move on to the next functions. Add function returns true if the item is added. It ignores the item if it is already present in the hash table. For example, if a hash table has or a hash set has GFG, courses, and IDE. Now if I insert IDE again, add function will not add this IDE, will return false, right? If something is already present, then it adds and returns true. Otherwise it ignores it and returns false. One more thing about traversal. When you traverse a hash set, there is no guarantee of any order in the output. Any item can be printed at any place, right? They can be printed in any order. So orders can be different when you traverse through the hash set for different set of items. Let us now talk more about the more functions here. Size function is used to give you size. Here the size is going to be 3 because there are 3 items. Now remove function, it removes an item, the given item from the hash set. If the item is present, then it removes it and returns true, otherwise it returns false. After removing the item, you will get the size as 2. So you first got the size as 3, right? And then you got the size as 2. Here is another way of traversing through a hash set. I have used for each loop here. In the earlier example, we used iterator. This is a simpler code. We use a for each loop using colon, and we print all the items one by one, traverse through all the items one by one. Let us talk about isEmpty function. IsEmpty function returns true if the hash set is empty, does not contain any items. If it contains any item, it returns false. So this function here will return false because there are two items after removal of IDE, so it will return false here. There is one more function, clear. So clear function is used to clear the content of the hash set. So if I call clear here, for example, after printing this size, I call h.clear, and after calling h.clear, if I print system.out.println, right, if I print h.size, what will I get? I'll get 0 because I've cleared the hash set. This clear function is especially important when you are using hash set for multiple test cases. You can just create one instance and call this clear function after every test case, right? If you want to clear the hash set after every test case, right? So you just have to create one instance and can use it for multiple test cases by clearing the content for the previous test case. Few more things. You can create a hash set by specifying an initial capacity, right? You can specify for optimization purposes. If you already know that your hash set is going to have 10 elements or n elements, you can specify that initial capacity. That will help in optimization, right? Your compiler or interpreter will internally optimize that for that size. Let us now talk about time complexities of different operations on a hash set. These three main operations, add, remove, contains, which is to add an item, remove an item, and check or searching an item, right? So all these three operations are big O of 1 on average because they use hashing. Size and isEmpty, they are big O of 1. IsEmpty can be just done by checking if the size is 0 or not. Size is internally maintained with the collection, so it's just big O of 1 to get that member. So in this video, we talked about HashSet. HashSet is implementation of hashing. Wherever you need to write a Java program for a problem where you have search, insert, and delete operations to be done, or any subset of these operations to be done on a collection of items, you can use a hash set.